Today we will be analyzing the biomechanics of the triple jump. The goal of the triple jump is to achieve the greatest distance from the start of the hop phase to the end of the jump phase, or landing. During the triple jump, the jumper attempts to maintain as much horizontal velocity as possible to achieve maximum distance. The triple jump is comprised of 4 phases, 3 of which are jumping phases: the approach, the hop, the step, and the jump. The approach phase is the acceleration leading up to the hop phase. The goal of the approach is to build up as much velocity as possible to lead into the 3 jump phases. The approach is considered the most important part of jumping because the greater the velocity during the approach, the greater the potential distance will be for the jump.
Hop jump. The takeoff leg is fully extended with hip joint extension utilizing gluteus maximus, knee joint extension utilizing rectus femoris, vastus lateralis, vastus medialis, and vastus intermedialis, and plantar flexion of the ankle via tibialis anterior, extensor digitorum longus. This position allows for triple extension of the knee, hip, and ankle. Triple extension maximizes the force that an athlete can apply to the ground and allows for the jumper to travel farther. The drive's knee's thigh is parallel to the ground and the shank is perpendicular to the ground. Both knee and hip flexion are active. The ankle joint of the dry knee is dorsiflexed. Assuming the jumper is doing a double arm swing technique, both shoulders will undergo shoulder flexion to help the jumper's momentum drive forward. Hop flight. During this subphase, a cycle is done with both legs so that the same leg is able to jump again. The jump leg cycles from a position of full extension to a position of both hip and knee flexion. The opposite leg will perform a reverse cycle, going from hip and knee flexion to hip and knee extension. Just before landing, the jump leg will undergo hip and knee extension to cushion the landing. During flight, arms will undergo shoulder extension to revert back to a jumping position. Hop land. The takeoff leg is also the landing leg. This leg is mostly extended during landing and is more in line with the body's trunk with the flat foot with the ground. The hips and the knees are both flexed. The opposite leg will be brought from behind the body to in front via hip flexion.
The step phase is the middle jump of the 3 jump phases and consists of 3 subphases. The 3 subphases are the step jump, step flight, and step land. During the step jump phase, the takeoff leg is extended with the hip and knee joints extended. The muscles used by the hip are the gluteus maximus and the hamstrings, consisting of the biceps femoris, semitendinosus, and the semimembranosus. The muscles used by the knee are the quadriceps, consisting of the rectus femoris, vastus lateralis, vastus medialis, and the vastus intermedius. During this phase, the foot is plantar flexed using the gastrocnemius and soleus muscles. The opposite leg during this phase is positioned where the thigh is parallel to the ground and the shank is perpendicular to the ground. The hip and knee are both flexed with the foot slightly dorsiflexed. The main muscle used by the hip is the iliopsoas. The muscles used by the knee are the hamstrings, which consist of the biceps femoris, semitendinosus, and the semimembranosus. The muscles used by the ankle joint are the tibialis anterior, extensor digitorum longus, and the peroneus tertius. The second subphase is the step flight phase, while the takeoff leg's thigh is perpendicular to the ground and the shank is parallel to the ground. The hip joint is extended using the gluteus maximus and the hamstring muscles. The knee joint is flexed using the hamstrings. During this phase, the opposite leg is in knee dry position, where the thigh is parallel to the ground and the shank is perpendicular to the ground. Both the hip and knee joints are flexed, where the hip uses the iliopsoas and the knee uses the hamstring muscles. In this phase, the shoulders will start in a forward flex position and move to an extended position, creating arm swing during the flight. The final phase is the step land phase, during which the legs essentially switch roles. The takeoff leg now becomes the knee drive leg. This leg is now positioned so the thigh is perpendicular to the ground and the shank is parallel to the ground. The hip joint is extended and the knee joint is flexed. The hip uses the gluteus maximus and the hamstrings. The knee uses the hamstring muscles. The opposite leg during this phase is slightly extended in front of the trunk of the body. The hip and knee are both extended with the foot flat on the ground. The hip uses the gluteus maximus and hamstrings, while the knee uses the quadriceps. The final phase is the jump phase, which involves the landing into the pit and ending the triple jump. The jump phase consists of three subphases: the jump jump, jump flight, and jump land. In the jump jump phase, the opposite leg is now the knee drive leg. The hip and knee are both flexed, while the foot is plantar flexed. The major muscles used by the hip joint is the iliopsoas. The muscles used by the knee joint are the hamstrings, which consists of the biceps femoris, semitendinosus, and semimembranosus. The ankle joint uses the gastrocnemius and the soleus muscles. The other leg is extended and making contact with the ground. This leg extends at the hip, knee, and ankle to perform the final jump. The ankle extends via plantar flexion. The muscles used by the hip are the gluteus maximus and the hamstrings. The knee uses the quadriceps, and the ankle uses the gastrocnemius and soleus. The shoulder undergoes shoulder flexion to help drive the arms forward. In the jump flight phase, the drive knee will stay flexed at the hip, and the knee and the shoulders will be in high reach position. The takeoff leg will cycle from hip and knee extension to hip and knee flexion. This cycle brings both legs together to create a knee drive position for both legs. The shoulder will row forward via shoulder extension using the pectoralis major, latissimus dorsi, teres major, and deltoid. The trunk will flex using the rectus abdominis. Just before landing, the knees will go from a flexed position to an extended position. The jump land phase is the final phase of the triple jump, consisting of landing in the sand. Both legs are fully extended in front of the body, with the feet slightly below the hips. Just as the feet hit the sand, the jumper will flex the knee and push the hips forward toward the feet. Arm motions will help with balance during the landing.
It should be noted that many elite jumpers land into the sand in an alternative style. This style of landing on their side, as shown, helps to propel the hips forward, increasing distance in the sand. During the first phase, a jumper's optimal angle is 16 degrees. This angle is best because it allows the jumper to stay in the air long enough to cycle, but not too long so that the landing can be controlled. The second phase has a much lower angle of 14 degrees. This is so that the jumper can maintain neutral hips while still traveling a maximal distance. The final phase is the largest angle of all, at 22 degrees. This is both because the jumper has to prep for landing in the sand and because the athlete is slowing throughout the jump.
Triple jumpers are most susceptible to lower body injuries. Studies have shown that ground contacts in triple jumps are 4 times higher than when walking. The triple jumper's body is having to endure 4 times more force than normal. Therefore, the force being produced through the triple jumper's legs is very high. The most common injuries in the lower body of a triple jumper are foot, ankle, and knee injuries because the foot and ankle and knee were not made to endure this much force this many times. Injury can occur. To prevent injuries, strength and proper technique is needed. Patellar tendonitis, degeneration and inflammation of the patella tendon is the most common triple jump injury. Ground force reactions are high in jumping activities and will be even higher on artificial surfaces. This will cause anatomical structures such as fascia, ligaments, tendons, and bone to bear the load during high-stress activities such as jumping. Wireless, the effective use of higher ground reaction forces are useful in a performance aspect. In an injury prevention viewpoint, excessive amounts of jumping on hard surfaces will eventually lead to injury. The degree of anatomical resilience of an elite athlete will determine when this happens. A typical elite triple jumper will stand around 6 foot 1 inches, weighing around 170 pounds. Lean muscle reduces the chance of injury. Lean mass decreases the amount of extra force needed to lift the body, making the triple jump more successful.
During this final video, take a look for the 4 phases: the approach, the first, second, and third phase, and ending with the landing into the sand.